Hi, I'm Juniper, and today I'll demonstrate a fantastic web automation tool created by Gino that fills in work hours using Python and an API. First, let me give you a brief overview of what we'll cover today. We'll start with the problem context and the specific issues that Gino's automation addresses. Then we'll dive into the code walkthrough, where I'll highlight the key parts of the script and how each problem was solved. Finally, we'll see a live demo of the automation in action, showing how it retrieves work hours, formats the data, and submits it automatically. This tool automates the tedious task of manually entering work hours, saving time, and reducing errors. Next, let's dive into the code. I'll highlight the key parts that make this automation work and address some specific problems encountered and solved. First, necessary libraries are imported, including requests for API calls, pandas for working with Excel files, and Playwright for browser automation. Environment variables are loaded from a .env file to securely manage API keys and user credentials. The script starts by defining the input file location for the Excel sheet and setting up the API details, including the endpoint for fetching time entries from Clockify. Headers are configured with the API key for authentication. The fetch and prepare data function is crucial as it handles multiple tasks. It first tries to read any existing data from the Excel file. If the file is not found, it initializes an empty data frame. The function then includes a helper to convert time intervals like PT6A5M into decimal hours, which is necessary because the form requires hours in a decimal format like 625. To map descriptions to specific hour types, a function is created that assigns the correct type based on the description provided. This is important for accurately categorizing the work hours. The function then fetches time entries from the Clockify API and normalizes the JSON response into a data frame. Clockify, a time tracking app used for logging work hours and estimating payouts, provides these time entries. The data frame adds columns to indicate whether an entry has been processed and to store the formatted hour types. Dates are converted from ISO 8601 format to DDMMYYY, and durations are transformed into decimal hours. To avoid processing duplicate entries, the script concatenates new entries with any existing data and drops duplicates based on unique IDs. The updated data frame is saved back to the Excel file, ensuring that no duplicate entries are processed in future runs. The run function handles the browser automation using Playwright. It launches a browser instance and navigates to the login page, where it fills in the credentials and logs in. After successfully logging in, the function iterates over each row in the data frame, skipping rows that have already been marked as entered. For each new entry, the script navigates to the form, fills in the required fields such as date, hour type, decimal hours, and description, then submits the form. Once the form is submitted, the entry is marked as processed in the data frame, and the updated data frame is saved back to the Excel file. By integrating these functions, this script efficiently automates the process of logging work hours in Clockify, ensuring accurate and timely submissions without manual intervention. Live demo. Now I'll demonstrate the automation in action. The script first fetches the work hours data from Clockify using the API and identifies entries that haven't been entered yet. As the script runs, it displays the entries to be processed, showing the dates, hour types, and decimal hours. Next, the automation logs into the web application, navigates to the form, and starts entering the data. It fills in each field, including the date, hour type, and decimal hours, then submits the entry and marks it as processed in the Excel file. The script repeats this for each new entry, ensuring all data is accurately logged without duplicates. You can see the terminal output, confirming each successful entry. This demo shows how the tool efficiently retrieves, processes, and submits work hours, saving valuable time. Conclusion. In summary, this automation tool, developed to streamline the process of logging work hours using Python and an API, effectively reduces manual entry, saves time, and minimizes errors. By addressing key problems such as formatting hours, converting dates, avoiding duplicate entries, and handling various hour types, the tool enhances productivity and accuracy. Looking ahead, Several enhancements, like integrating with Google Spreadsheets, running the script on a virtual server, implementing robust error handling, and creating a user friendly interface, could further improve the tool's functionality and accessibility. Thank you for watching this demonstration. If you have any questions or need further information, feel free to reach out.